So tonight's topic, how to choose a collection. So we've already talked about this thing called generics, which are templates needed to use collections in Java. So collections are data structures. Collection is a way of organizing memory. And I want to give you guys a strategy for choosing collections. So we have these things called arrays that you know so well. But that's not a collection. That's also not a real way of using data structures. Arrays are never used. Arrays are contiguous. You understand this term? The memory is like one big block. It's all continuous, right? Contiguous. And cannot be resized. You cannot change, you cannot increase the size of an array easily. Or even, you just cannot change it. That's why this data structure is not useful. So when we work with java.util, is it util or util? Util, and then it also has this thing called arrays, right? But java.util.star has some additional collections. So, and they have three kinds: list, set, and map. Lists are just list of things, like names of people living in Cupertino. That's a list. Your set is also a list of things, but unique, right? So if I have a set of things, I'll have all unique, like California states, US states. Or counties in California. Set. They're all unique. There's no county in California that has, no two counties have the same name. Does that make sense? And then there is a map. These are list of keys things and values. So like Roman numerals. What other sets, maps do you know? Dictionary. Dictionary meaning word and meaning. And one word can have multiple meanings. But the key is always unique. Okay? So these are the three main type of data structures from a usage perspective, of maybe from a way that you organize memory. Okay? Now, list can be either contiguous or discontiguous. So contiguous because the size is small, it can be resized, right? Array list. Array lists are like arrays, the difference is array lists are resizable. You can grow and shrink. Discontiguous is linked list. So linked list combats memory fragmentation very nicely. In case of a array list, when you increase the size, if the size cannot be extended where the array list is located, array list contents have to be moved to a newer location before it can be resized. So that moving around can cost time, right? Discontiguous, when you work with a linked list, if you have to increase the size, it will just add additional links to memory areas that are available. So linked list doesn't live in one part of the memory, it uses available memory wherever it is, and then to access the values you have to go forward in references in the linked list. Right? So both of these, like linked lists can be, not both, but linked lists can be two-way or circular. You guys understand the difference between those two? So a linked list can have references that point to the nodes on both sides. So just to give an example, I guess maybe so if I have a list that starts and so if the nodes point both ways, right? And this is the head. So you can basically end up with a two-way linked list. Now, if you want to make a circular linked list, that is great. You can start anywhere in the list, and regardless of where you are, you can traverse the entire list in any direction. That's a circular list. So these implementations are done inside the APIs in Java. That's what we're talking about tonight. Okay. Then we have set. So you would use a list for things like lists are used for small size memory requirement. About 1,000 to 5,000 elements. And you still have the overhead of sorting, and you can apply things like sequential search or binary search. So let's get all the different data structures on the board, and then we'll talk about how to choose one, right? What is the potential algorithm for choosing a collection? Because that is often an interview question as well. And since this is your first look to data structures, and if you are able to capture all of this data or content, it's pretty good. We're going to look at this in advanced Java as well, and then of course the course in data structures covers this in a great way. Now set is a list of unique things, so you can't have any duplicates. Social security number is a set, phone numbers, set, employee IDs, set. So sets can be very large. Anywhere from 5K to millions of items. And Java provides two implementations, tree set, actually that is one word, and hash set. Tree set where data is kept sorted, and hash set where data is kept unsorted. So the question is, what is your requirement? If you want some really large structures in memory, and these days you have flash memory, so you can keep things in RAM. Even RAM is pretty humongous. So if you have a sorted structure like tree set, which basically uses a binary tree, and it is sorted, which means that every time a value is inserted, it has to be moved, things have to be moved around to make sure that the tree is sorted. Hash set, things are unsorted. And the search is really fast. Meaning, the hashing algorithm that is implemented in the API can ensure that things can be found with like one or two lookups, which is much faster than sequential search or binary search. Are you guys familiar with binary search? It's like if you have yellow pages and you need to find a number, you figure out the total number of pages, and you go in the middle, and then you go in the left part of the book or right part of the book, depending on your finding. Right?
Wait, which one's the bubble sort?
That's a sorting algorithm. Are you talking about search?
Oh, okay. Yeah.
So binary search is what is used in sorted structures. So when we talk about tree set, binary search. So it is pretty fast, but you have to keep in mind that to do binary search, you ought to have the underlying structure sorted. And even then, it's not as fast as hashing. Hashing does not have any sorting overhead, right? And it can find things fast. Did you have a question, please?
Yes. Is it sorted by size, or how is it sorted?
What?
Whatever the array set is. Would it be sorted by the size of the memory, or of each element?
It's based on the values, right?
Okay.
I'm talking about tree set. Tree set is sorted by the values that are in it.
So what if you have a tree set of name, well, it can't be names, right, because they all have to be unique. What if it's like a set of
Username.
countries?
Yeah.
Then how would that be sorted? Would it be by the length of, would it be alphabetically?
Alphabetically, right.
Okay.
So length of the string and lowercase, uppercase. Yeah. So values are numerical or string, and both can be sorted. because strings are also numbers at the end of the day. So there is a question on how hashing is so fast, right? I want to leave that for Monday. Hashing is this black box, and you tell it the value, and then what happens? It figures out where to store, and in between is the black box. Now generally the black box hashing algorithm that we teach in data structure courses is using the mod operator. When you guys go through data structures course, you will learn that. And oftentimes we say that hashing can cause collision because the black box can determine where to store, and sometimes it makes the same decision for two values. You are trying to insert 10 and 20, and both map to location 1, that's a collision. Then the question is, is it 10 or 20? Then how do you decide, and how do you do collision management? In Java API, what happens is the black box has dependency of these three things. Number of items in data structure that is being used, meaning the size, the value, and percent occupancy. Percent occupancy means that I am going to set up a factor of 0.75, which means that 25% of the memory will be wasted. So that way I have these empty locations always available in the structure, so the collision never occurs. So now the problem with this, yes, you can avoid collisions, which is very nice. So you can always find values quickly, and yes, you're also wasting memory. How many times do you need to resize your data structure because your requirements change? You might say I have 1 million customers today, and I want to now grow to 5 million. When you start writing the program, you cannot allocate memory for 5 million customers when you don't have them, so you're wasting memory. But if you end up changing the size, all the values need to be rehashed. And this is not to say that you run the program, you shut it down, and you run again. Well, when you run again, obviously new memory is allocated and we're okay. We're talking about resizing in the same JVM, in the same process. So the point is that you conjecture your business requirements large enough and set the size, and as long as you're okay with wasting memory, meaning memory that won't be used for a while, this structure works really well. So now you're looking at the search for items that are posted on eBay in a structure that is hashed. So if you are searching on items like iPad battery, so the keys are created and hashed. So when you search for those items, everything shows up. I think in the next advanced Java course, we should talk about how to build a good search engine. Maybe instead of writing the apps that we are writing these days, maybe we should write a search engine. Maybe you guys can do that for Lab 9. So like you have Twitter, right? You hashtag things. So how can you, with a single collection like hashing, create a multi-dimensional search structure? I have to talk to you guys about search. And we can look at Google search. One text field has changed the world. The user experience, the order in which those words are put. It's fantastic algorithmically to think about. So anyway, I'm talking about tree set and hash set. Hash sets are really nice, awesome for usage, for searching things fast. Anytime size is really large and the requirement is that you need to find things fast, hashing. So let's talk about one more pattern. Often when you think of collection, you think of creating, meaning adding records, reading, updating, and deleting. So this is an acronym that is used for representing all the operations you can do on data structure. Okay? So now when we start to determine which collection we are going to use, we start looking at the relative velocity of these. And let's decide which one is the first thing we must do. To search anything, you must create or insert, right? Then you read. It's only after reading, it's only after finding, you can update something. Or, for that matter, delete something. You can't delete something you can't find. So these relative usage is very important. So we can actually forget about update and delete, because update and delete is greater than read, because you have to be able to find to update, you have to be able to find to delete. So we can start looking at the relative velocity of create and read. So when we say read, we also mean update and delete. So what am I talking about relative velocity? This sounds like a very nice term. Let's look at the phone book, right? Do you call people more than inserting new records? Do some analysis. Go back and check your phone bill, right, for the last 6 months. Now check the number of contacts you have in your address book. Let's say 500 or 250. Those are normal numbers, right? Unless you teach at De Anza and then you have like 30,000, because every email address you get becomes your contact. But now you start looking at the phone calls you make. And you call about 20 people every month, maybe, and then to those other 50 you send a bunch of text messages, like 20,000 text messages a month. I'm not making any suggestion. Point I'm saying is, I'm not judging, I guess. What I'm saying is, look at the velocity of reading the context database, and writing values to it. So we start, that's the meaning of relative velocity. Usage of a database where you do more reads versus inserts, right? Those elements are foundational to figuring out which collection to use. So if I'm doing more searches in a very large data set and less number of inserts, I'm going to use a hash set. And is there a need where I need to keep a sorted structure? Yeah. I mean, if I need to print the yellow pages to distribute to the world, like if let's say every city was still doing that, are they?
Yeah. Unfortunately.
Okay. So,
Not every city.
but okay, it's happening. I heard one person say it. I got yellow pages in my city as well. But that was like once every 2 years or once a year, whatever. But before they used to do it once a month, right? All the trees and so on. Yeah, those were the days.
No,
I mean, before internet.
it's way back
No, thanks.
Yeah, way back in the day, and I'm proud of it. Life was better. I'm not going to say it. Because I will go off the track. So, tree set, you have to print the yellow pages. You would use a tree set for that. Because you need a sorted structure, and you can go down the line, right? So, that's what we mean by relative velocity. Then you have maps. Map is like for yellow pages too, actually. That's a real map. You have a map of phone numbers and people's information that's associated, with phone number. So phone number is the key, it's unique. So we have tree map and we have hash map. Okay? So these are the 6 collections or data structures I'm requesting you to get to know. So I want to cover a few examples so you can know how each one of these work. Like how to use an array list, how to use a linked list, and so on. Now, how do you decide which collection to use for what? So the determination is done size and rate of insert versus read. Those are at least the 2 factors. Because if you're going to insert versus read and then size. So if the size is small, like your phone book, 250 entries, it doesn't matter. But if you have 30,000 entries and you're syncing your phone with email and calendar, because contacts are available, whichever apps contacts are available in, right? If you have to start syncing between those, then you have to be careful about the collection size. And also the magnitude of usage. I mean, if you think of Gmail contacts, and how many Gmail users are there? Right? So now we have to, how do you tackle the memory for each contact database for each Gmail user? See, that's a big data problem. So these are things that designers think about before deciding which collection to use. Now, data structures wise, like I said, life is really easy because we can go and just look in java.util and we can find APIs to use for all of these. So